Okay, so now we are going to actually find the theoretical probability of some chance experiments. So we have to find the sample space first because we need to know what are all the possible outcomes. Remember that was that bottom part of our formula. And I'm actually going to write out our formula so we have it on this page. So the formula, remember, is the probability of an event equals the number of favorable, so whatever it is that we're looking for in that moment, favorable outcomes over the number of possible outcomes. You know, I have beautiful handwriting. You're so jealous. So consider a chance experiment of rolling a 6-sided number cube with the numbers 1 through 6 on the faces. What is the sample space? So the sample space, remember, is all the possible outcomes. So we can get a 1, a 2, 3, 4, 5, or 6. List the probability of each outcome. So what's the number of possible outcomes? That's what I'm going to write out first. I always want to know what's the possible outcomes. Well, there are 6 because there's 6 sides. So that's 6. And then the probability of rolling a 1 is a 1 out of 6 chance. So then we will write out the probability of an outcome. Remember, that's only when we do it one time, is 1 over 6. Because it's the number of possible outcomes. Then it says, what is the probability of rolling an odd number? So I know that I have 1 is an odd number, 3 is an odd number, and 5 is an odd number. So the favorable outcomes is the odd, and that equals 3. And then the number of possible is 6. So the probability there is 3 out of 6. Or, and I've told you this over and over and over again, you want to simplify to 1/2. Then what is the probability of rolling a number that is less than 5? So is that including 5? No, we just want to know what's less than. So there's, let me use a different color. 1, 2, 3, 4. So the number of favorable, and I'm going to write this out every single time, is 4. And then the number of possible is 6. So 4 out of 6, or 2/3. So that's the probability for that. Okay, then I'm going to turn the page to exercise, I'm going to go to the next page, to exercise 2. This one says, consider an experiment of randomly selecting a letter from the word number. So a letter from the word number. What is the sample space? So I'm just going to write out the letters. I could pick an N, a U, an M, a B, an E, and an R. None of those letters repeat themselves, so I can just write out each one, and that's 1, 2, 3, 4, 5, 6. Again, my possible outcomes is 6. And remember that when we were finding the probability of an outcome, it's 1 over the possible, which is 6. And then, what is the probability of selecting a vowel? I'm going to go ahead and underline my vowels. Vowels are A, E, I, O, U. So U and E. Number of favorable, because I'm looking only for vowels, is 2. And then possible is 6. So here I have 1/3. Then the next one is, what is the probability of selecting the letter Z? Ooh. Is there a Z anywhere in here? So the number of favorable equals 0, and then possible is still 6. But the probability here is 0. This is one of those impossible things. So we talked about how there's like certain, equally likely, or unlikely, more likely, and then impossible. This one is impossible. Okay, so for number 3, I'm actually going to give you guys the steps. I'm going to write it out because I've been doing it, but I want you to like have actual steps for what to do. So it says, consider an experiment of randomly selecting a square from a bag of 10 squares. And it says, color the squares so that the probability of selecting a blue square is 1/2. The probability of selecting a blue square is 1/2. So there are 10 squares. That's my number possible. So the first thing I always want you to do is identify possible outcomes. In this case, it is 10. The second thing I want you to do is to identify your favorable outcome. So here we know that our favorable outcome is always going to be the numerator. The favorable outcome is always going to be our numerator. So they already gave us our probability, the probability of an event. So we're working a little bit backwards here. But I know that the numerator is favorable and the denominator is possible. Now, again, I have to work a little bit backwards on this one because they've given me the probability, but their possible outcomes doesn't match up with the number of actual possible outcomes. So I know that the actual possible outcomes is 10. And they've told me my probability is 1/2. So I'm doing y'all's favorite thing, which is scaling up and scaling down. How do I get from 2 to 10? I multiply by 5. So then I know that the numerator, which is my favorable outcomes, will also be multiplied by 5. So I actually know that 5 out of the 10 blocks are going to be blue. So I'm actually going to go color those. And it doesn't matter how you color them. I'm feeling a little out there, you know? Okay, so here we've done 2 steps. Identify the possible outcomes. 2, identify favorable outcome. The third step would actually be in this case, or not in this case, but typically, is to find theoretical probability using P event equals number of favorable over the number of possible. And I'll make sure to go ahead and just like give you guys a clip of this in the slides. Okay, I'm gonna do one more and then I'm done talking, I promise. We're just skip B and we'll do number 4. Students are playing a game that requires spinning the 2 spinners shown below. Oh, we're just gonna stop.